Okay, we have equation of a circle. Now, last week I did a brief overview on the equation of a circle, and we had a diagram, and I showed you kind of how to solve it and what it looked like. So here, this one just goes a little bit more in depth. Now, real quick, it says, by definition, all points on a circle are equidistant from the center of the circle. As you might imagine, the algebraic definition of a circle is based on the distance formula. So, equidistant means that they are the same, the points on the circle are the same length in between each other, okay? And basic equation of a circle, this is what we have here. It shows us we have a right triangle, and this is basically kind of how we're able to figure out the points on it, or the equation. So in the simplest form, it's x squared plus y squared equals r squared. Here's where our right triangle comes in for that, okay? Now, so what this means though, above the equation, let's see. It's a simple result of the Pythagorean theorem with the triangle a squared plus b squared equals c squared. Okay, you have the right triangle here. X squared plus y squared equals r squared. Pretty similar. And then here's the example right here. Circle with the equation x squared plus y squared equals 64. Is a circle with its center at the origin, radius is 8, okay? 8 squared is 64, there we go. And solving for the radius, here's two examples how you would solve for the radius. Typically though, you'll be solving for the circle. Now you see the points on the circle. Let's just say these are the radius points. These are right in the center of the circle. Here's our radius. Let's just say that. Okay, now let's go to our slides. But what we're going to do is we'll skip the questions again because I'll let you answer these on your own now that you know the equation. Okay, now we have this right here. So this is where it gets a little complex and it could seem super confusing, but it's pretty much the same. We have x minus h squared plus y minus k squared equals r squared. Okay. And you know what, while we're at it, we'll take a look at this video about it real quick.
Now that you know what the conic sections are and why they're called conic sections, let's see if we can understand the actual equations of the conic sections a little bit better and use that knowledge to be able to at least recognize them when we see the equation, and then if we see the equation, know how to plot them. So the first one we'll start off with is the circle. The circle. And you've probably seen this for many years already, but I'll review if you don't know it already. The general form of an equation, or the general equation for a circle, is x squared plus y squared is equal to r squared, where r is the radius of the circle. And this would be a circle centered at the point 0, 0. So I'll just draw this kind of general graph right here. So that's the x-axis. That's the y-axis. The circle will look like this, in a different color. The circle would look something like, make sure it's a circle. Well, it's supposed to be centered at 0, 0.
Okay, well, here's our circle that he's drawing.
Center will be right here.
And that's the radius right in the center.
From the center to any point along that circle will have a distance of r. So we go from there to there, it's r. From there to there, it's r. From there to there,
yep, and all of those points that he has right here are a radius. So we won't go too much into the video. I'll play for just a little longer.
This formula, all it is an extension of the distance formula, which is really just the extension of the Pythagorean theorem. So for example, the distance formula, if I want to know the distance between some point x comma y and the point 0, 0, what you do is you take the difference of the x's, so x minus 0, you square that, and then you add that to the distance between the y's squared, so that's 1 y point minus 0 y, y is equal to 0, square that, and that is equal to the distance squared.
There we go. So there's the distance squared. Let's stop it right there. And let's move on to the next part. So we'll just skip the questions again. I'll let you answer all these questions on your own because it'll be a little bit easier once you have the formula and now that you know a couple basic facts about it. But here's a couple little tips and tricks about completing the square, okay? So it says you may not always be given the equation in a standard form. So here's some things that you could do to help yourself if you're not given the equation of a circle in the standard form. And okay, here's an example, another example of the equation. Here's what you would do. First, here's your equation. Then you divide both sides by the coefficient, okay? Then move the constant term to the right side. Then you rearrange the terms on the left side. Add the squares of half the coefficients of x and y to both sides. Then you group the terms, and then you simplify using the identities. So the identity property. Okay, and now here's another one. The circle isn't quite in the center, but still basically same concept. Here is the general form of the equation. Here's the standard form. Standard form is going to be a lot less confusing for you. Okay, and again, I'll let you solve these equations on your own and solve this on your own as well. And here is the summary. Here's just showing you different types of circles. So in short, it is related to the Pythagorean theorem. And if this tutorial is a little bit confusing, I recommend you find the other tutorial I did, the brief one about just the equations of a circle. That one will be a little bit less confusing for you. And enjoy.